What about this one? Okay, cool. Love it. Love it. We're back. Back. Okay. So, I went to that place, Singapore, for the weekend. Fantastic. Lots of fun. Love the airport. And yeah, I'm back now, and I'm gonna try and catch up on some adventures. So where we left off on Friday, which I think was the last time I did a stream, is we've got this filter pushdown issue. It's impacting like a production thing, but I got a workaround for it, so we're not in a huge rush. But you know, I do want to like fix it right eventually, as opposed to kind of like the half-ass fix that I've got right now. And fixing it right also means like getting it reviewed in open source and getting everyone to agree on sort of the same page. And so one of the concerns that was brought up was like, hey, you know, doing this selective filtering pushdown, we could end up like, well, we'll save this filter double compute logic. You know, it might be worth the filter double compute in some cases. So like this isn't a clear win. It's a win for some cases, but not for all. And I hear that concern. I don't think it's like super valid, because I think we can work around it with the mechanism that we introduced, whereby we like use some heuristics to figure out like, hey, is this likely to be an expensive or inexpensive thing to compute, and use that to decide whether we do a filter pushdown. But I think we can make it more clearly a win. That is something which is like always the right thing to do, and so we should try and do that. And so that's we did some work towards that on Thursday. We didn't go all the way, but we made some progress. But you know, that's life. So we're gonna work on this. So what am I doing? Right. Okay, I'm gonna do a quick little tweet saying like, hey friends, come and join me. Come and join me for trying to make filter push down through projections even better. Yay! JK, but also not. Well, let's yeah, time box to hour with a mini copy quest. So I got like an hour to hack on this, and I don't know if we're gonna make a lot of progress, but we are gonna see what we can do. And yeah. Okay. What am I doing? Oh, right, all the things that I just said. But my memory is, come see, come saw. So, next thing that we're going to do, I have a text message. Make sure it's not like, hey, you've been fired. No, cool. Not that would happen over text message, but, you know. That's probably more of a, I'm not able to, actually it might be a text message, because they'd probably shut down my, anyway, whatever. Let's focus on happy things. And those happy things are hacking some questionable code. So, where we left off yesterday was the idea that what we might want to do instead is break up our filter, break up the project as we're pushing our filter down through it instead of using the heuristic. And so this is, probably we're not going to get it right initially, but it is a place for us to start, and so that's what we're going to work on. So here what we're saying is, if we are pushing something down, we're going to have a top level projection. And actually, let's write this down. if we're pushing something through the projection, we'll end up with a filter plus 2 projections. We'll end up with at least a filter plus at least we will need to introduce a new projection which projects the elements used in the filter. If left behind LMs dot is empty, unless we use all elements in our projection. Okay, well let's start with this. To do special case when left behind LMs is empty. Otherwise, we'll loop infinitely. Plus filter aliases dot iterator dot map underscore dot underscore 1. Think. This is a place to start. Everything's going to fail, but that is okay and pretty normal in my life. Let's go ahead and great, fails. Cool. So, here we go. Ambiguous reference. This is going to be line 74. No. This is alias helper. Okay. Hmm. 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 Okay. Yeah. And then over here, we're going to find dot empty alias. Match expected type. What? Ah. Take an attribute map of type alias. What? The fuck? Computers. Okay. Hmm. Hmm. Gotcha. Okay. Um. Um. Yeah. Okay. And you are then going to be um. You are going to be new expert. Yeah. And then we give back new expert and replace. Well, let's get some Techno Axe royalty-free music going. Also gonna try and drink this water. As soon as I finish drinking all my water, I can get more coffee. Hmm. Okay. This is gonna be place aliases while tracking. Uh, left behind aliases, left behind okay. Used aliases, iterator for each, left behind aliases. For each. Okay, let's go take a look at our attribute map iterator. Type attribute comma alias, and then we remove used aliases. This is oh, what am I trying to do? Just got here. Awesome. Thanks for dropping in, Yamesh. So today, what we're trying to do is in Spark, we have a thing where we push filters down as far as we can. And this is important because pushing filters down gives us the opportunity to read less data. That's the big one. And also generally compute less data. So what we're trying to do is we're trying to take advantage of that. But we're also trying to make sure that when we do filter push down, that we do more intelligent filter push down, I guess. So pushing things past a projection, we sometimes extract aliases, and we do some smart things there. But it's not perfect, and so we're trying to improve it so that when we are pushing down and we're pulling things out of the alias map, we don't end up in the situation where we double compute certain things from the alias map. And that's what we're working on today. Cool. Okay. We'll need to introduce, so for which projects the elements used in the filter. Alias helper line A1. Cool. Let's see how this goes. Oh. Like it compiles. That's progress. Hmm. Okay, cool. Um, hmm. Okay. So plans do not match. That's sort of expected. But okay, so it compiles and then the test fails. So that's okay. So progress. So um uh, and left $sign. Hmm. Oh, yes. Filter aliases. Um, aliases to push for filter and left behind. Hmm. Hmm. Okay. So here we go. We start with aliases to push for filter. So we're pushing down a greater than 5. But we're not. What? Hmm. Yeah, so this isn't working, clearly. Um, oh, okay, yeah. So this then filter aliases plus use aliases. Let's go ahead and, okay. While pushing. Hmm. Hmm. Use $use aliases on $con. The on $replace $. use this. So we are, in theory, pushing and leaving up but we shouldn't be doing that. We should be pushing all of them? Oh, I guess... Wait. That's the one that I care about. So, previously, inside of optimizer.scala, what did we do? So, previously, there was no stay up, push down, stay up. We pushed everything down. Right? Unless it was... yeah. So, actually, this simplifies things a lot. Figure out what our map is to be. So this is no longer push down. Stay up is always going to be empty. Okay. There's no double eval to be avoided, and we don't need to move any project elements around. Now we might get the infinite loop in the test. Maybe not. Okay. So left behind isn't working. Like that just isn't working. So our attribute is, let's go look at alias map. Attribute map. So attribute map is yes, okay, that's why. Left behind alias is Mm. Right? Alias map. Found. But that is the same thing. Is it not? Oh, god damn it. This fucking... the type signatures here. Because removed. Okay. Cool. Cool. 1799. Yeah, okay. Let's go ahead. If left behind aliases dot contains huh. Oh, hey Babu. I'm good. Writing some code. Mixed success. Ugh, the left behind map is still... Oh, actually no. That looks pretty reasonable. This is good. So, what happens here? Just doing okay. Her back's getting better, so that's good. So, initially what we do here... So, okay, what we want to do... so we've got our pre-filter projection and our top-level protection, and Okay. So here we go. So the thing that we want to do is we're gonna have okay. If left behind aliases dot is empty, let's handle this special case. If we need everything in this projection for the push, we don't move anything. Okay. Otherwise, we make a pre-filter projection, a top-level projection, and we do actually we make a filter. We actually can take our original filter so we take our top level projection, we apply it to our filter, top level, okay, that's probably gonna fail, but hopefully, thank you. It's really sweet. You too. Let's hope this works. Okay, so what we do is if the left behind alias map is empty, nothing to push. And then I guess the other one here is pre-filter projection. So if if filter aliases dot is empty, okay. Filter child we if it is not empty, Otherwise, if our filter being pushed does not reference anything in the map, YOLO, anything in the map, we don't need a new, doesn't reference anything in the, does not reference any alias in the project. We don't need a new projection. And then f.copy. Okay. F dot filter child. Okay. Filter child. Does that sound right? Okay. So here we go. So we make a new, we project filter as J0. Okay, so first thing we do, we have our local relation. On top of that, wait, no. Does this sound right? Yeah, okay, first thing we do is we have our local relation. We project A0, E0, and R-like, and then we filter, and then we have our project. So that's semi-reasonable. Now we can be even more aggressive here, and that'll get us closer to our target plan. So, if we need everything in this filter, in this projection for the push, we go down a different case. We try and split the filter. And actually, I think Okay, yeah, this is... This code is getting increasingly complex, and I don't love that, right? Like, but it is the kind of thing where, like, yeah, maybe this complexity is actually worth it. So what we're gonna do now is um, there's no double filter to be avoided. Okay, so then if say up is empty, this should not happen. Actually, yeah, let's go ahead. If pushdown is not empty, yeah, say up should always have something, since we had a non-empty left behind aliases. Since we had a non-empty left behind aliases, and left behind aliases is since we had an empty left behind aliases and left behind which means that there was something referenced, which means that the filter references all aliases, so at least one ln in our split filter. Let's reference something and therefore not be eligible. Okay, these comments are, oh, this code is getting a little in the weeds, but that's life, right? I think I've almost finished the water. Let's go take a look. A as a 0. Hmm. So we start with that. The first filter, push, the 5, that looks fine. Then we take the elements that we kind of expect, which is A0, E0, and R like as F0 introduces a new field. Makes sense. Then we go ahead, we filter. And yeah, so I think my expected plan that I wrote is not 100% on the money. So let's go ahead and we're going to go back to our filter, push down suite. So we would want this to have a greater than 5, and we select a R like magic as FE. So we agree here. We agree here. This is where we don't agree. Oh, okay, that's, we want to do the column ref magic. So A, E, and then we do a where on F, filter, the final projection here also disagrees. What did we do here? So here we should end up with A, F, and J. And that is also A, F, and J. So it looks like I screwed up here because this A0 should still be present, but it's not. It's not ideal. But let's see here. Why did we screw up? Take a look. Okay. These are the same. These are the same. These are the same. These are the same. This is not the same. So, aliases to push. So it's going to be probably our first one, where we've got an F11 and a left behind, but we're missing A0. Somehow we still have F0 though. Why would we have F0 but not A0? Where am I getting my references from? Okay, so here we go. We've got our projection is the references of our original projection, right? That's a filter child. Okay. So filter aliases. This is wrong, I think. That seems like the part which is wrong. To me. Okay, let's read the comment we wrote. Our top level projection is going to be the existing projection minus the filter aliases, right? So that's going to be left behind aliases, but added back as A for all. So that's the adding them back part. The filter aliases is not. That's why we have F0, because we use that. And why we're missing A0, because we don't ever actually filter on A0. Okay, left behind alias. So that's a left behind map. Oh. So left behind aliases is represented as left behind aliases, which is represented as left behind aliases. Which is left behind aliases. We also need all remaining references. So the references here, project.references.toSequence. Okay. So that's going to be oof. Okay, project.references sequence dot filter left behind does that sound right? Okay. Can you push down fields subject to R-like? That's a great question, PPT. So, that's sort of, so here's why what we're trying to do here. So we're trying to push down the R-like that is used. So we do try and push that field down. So if we constructed like a complex field and then wrote a filter on top of it, in theory we'd push that down. We should try and do that. Okay, that didn't work. Because now all we've got is that projection. So is this what I want? A0 and E0. What about F? Do we need E0? Oh. Yeah, sorry. Okay. Which Okay. Our original query, we've got F and J. So we would expect F and J. Is that what we got? No. Okay, let's go basic logical operators. Um, hmm. Okay, yeah, actually, project dot output. Does that sound right? We take the output of the expression. I always thought you can't push down fields subject to complex processing. How would? Okay, yeah. So that's right. So the thing is, like, we can push down the entire R-like expression, or if we made a complex field, um, yeah, can't push it. So let's okay. If we look here, right, like part of our goal in the filter push down change is to say like, hey, if we've got this, like we're computing this, right? We're computing this complex logic, and we can push it down. Now there's different kinds of push down, right? So this is talking about pushing it down within the query plan, right? And so that just gets things evaluated sooner. Now we probably, for most situations, can't push R-like down to the storage engine, unless the storage engine happens to be like a SQL engine that implements R-like. But that is a good point, and actually something we could conceivably do, push the storage layer, could be on any fields with where we're doing an evaluation like this. R-like is null and tolerant, so we could conceivably push that part through. Okay, does this... this looks right, except we're gonna but yeah, pushing down the null checking is a great idea. We should probably be more aggressive about that. I think this might work. We also need all, which is left behind aliases, plus all of the output fields which we effectively pushed down. Oh, now this code passes the test. It's super gnarly. And I really want to write more tests though, because this code's gotten more complex than it was earlier. And so I'm not um gonna make sense. Um, $, F. Okay, I'm trying to think about like what a good additional test would be to write. Um, uh, ooh, okay, Alexa, stop. So, I mean, I think this is a pretty solid place for us to stop for the day. We got it working. I want to add more tests, and take out the print lens. But we got it working, and so that's pretty good progress, right? For the day. So let's do a git commit and push it. Okay. Fill out how we do our filter push down to also push the parts of the projection that we are using. All right, cool. So we'll do a git push. It's great, and I'll come back to this maybe tomorrow, maybe the next day. Sort of, we'll see. Thanks so much for joining. Thanks PPT for asking questions. Umesh too. Great to see you, Babu. Have a lovely rest of the week. Just in case work comes up and I don't manage to come back and see you all again. Thanks, everyone. Bye.